Okay, we are in chapter 9 now, and the main focus of this next video is going to be auxiliary views. And what that means is that in addition to having the front, top, and right view and isometric views, we might actually replace some of those with an auxiliary view. And the view that we want to include is one that's face onto the surface to give us an accurate diameter. So let's get started and make sure that we select a part file that's going to be in inches. And we have to make the part file first before we make the PDF file with the views. So we do want to go ahead and follow the standard model-based definitions as we move forward with this and try to get all these dimensions on the part as shown. Now the base of this is going to be 3 inches by 3 inches and raised up 0.375. So we'll start with that, sketch two-dimensional, and we'll put this on the bottom plane right here. And we'll begin our sketch. And let's see, not showing completely. I wonder if it's because of how big this is. All right, well, we'll just go ahead and do it this way. So how about a rectangle? Let's make it a center rectangle. That way everything is nice and symmetric. And constraint dimensions. And we're going to make that 3 inches. And sorry about that sound. That really needed to be 3 inches instead. And we'll do the other one the same amount and then raise it up 0.375. Or we could have made them equal using a constraint. Either way should be good. Let's continue with the extrude, three-dimensional extrude. And then we're going to type in 0.375. And let's see. All right, let's get the whole thing visible again. We need to have a base that's centered on this plane right here as well. So I guess what we can do is maybe just draw on this plane again. And then I suppose what we can do is maybe a 2-point rectangle, just going from here to over here. And then I wonder if we could go ahead and use one of the symmetries. See if I can figure out how to make it so it's showing all of these. It looks like it's just showing the shortcuts for some reason. I'll see if I can find that out. All right, so if that happens to you, you can right click and say ribbon appearance and then reset ribbon so it comes all the way back. Now on this sketch, I want to go back to it and edit it and make sure it's symmetric. And I like to go over here to this symmetric tool and try to use it where you select the two items you want to be symmetric and then something in the middle. Now it didn't let me select the third object, so I guess we need to make a symmetry line for that. So I'm going to hit escape and go ahead and select a construction line that goes from midpoint to midpoint. And then see if it's locked into position by going. Now you can tell the order if you hover over, it'll tell you to go 1, 2, 3. So in other words, click the outer one, and then the inner one to make it symmetric. Now the gap that we're looking for here is going to be 1/2 inch. So let's see if that will help us out as far as getting things fully constrained. That's in the front of this, so we could go dimension right here, right there. And let's see if that makes it fully constrained at this point. It says 1 dimension needed, so wonder why it would think that's the case. So what we can do is right click and say show all degrees of freedom. So somehow it thinks it can move this one left and right, which I don't understand. Oh, right. Okay, so somehow this line right here did not get centered at the origin. That's what I was afraid of a minute ago. So there's going to me making that coincident. So that's how you work out those kind of issues. And then you want to extrude this up. And either we could extrude it up all the way to the top and cut away, or we can extrude it up and then try to make the triangle. Hmm. Let's see what we should do here. Hmm. I guess what we could actually do is just not even have that triangle there. I'm sorry, that rectangle, but yes, that might be okay. All right, anyway, let's changing my mind up as we go. If we go back to the isometric view on the view cube here, home position, let's try to draw on this plane that is this one right here, the XY plane. Let's sketch on that one. And let's just try to sketch that unusual shape that we see here. It's not symmetric. So let's start a new sketch here. Oh, it still thinks I'm on another sketch. So over here, right click, new sketch. And let's draw this shape that we see here, where it's got a short leg, angle, long, short, angle, and then long. So we're going to go up a little bit right here, and let's see. Oh, it's 1 inch from the top to the bottom, so that's interesting. What we could do is just type immediately 1 minus 0.375 and see if it will do the math for us and come up with that distance, so that the overall distance is 1 inch, but that's 0.625. Then we're going to go up, then horizontal, then down, and then back down here again. Let's make that fully constrained. And like I said, we might end up just deleting this other sketch. It kind of gave us an idea about how to extend it, though. Um, all right, so what else do we have here? Do we know the width of this top thing here? Not seeing that. But we do see that it's 1 inch from there to there. So let's start with that. So dimension here, there. Make sure that's 1 inch. And looks like it's got way too many digits here. So tools, document settings, units, and how about just 1.1, one place, and then 45 degrees. And remember, the way to handle this is to select this one, but there's no option to select this one, but you can select this one because it projects out in this direction. You can say 45 degrees. That's got too many digits here. So again, you can go to Tools, Document Settings, and change the angle display to just none. No, no dots, no decimal places, no places past the decimal. All right, then the total height from here all the way to the top is also known. So we'll go to Sketch, and I think it's going to be from there to there. We want to make that one 2.5. So it looks a little bit uh, odd in the sense that it doesn't really look like this diagram here, but once we get it expanded, we will check to make sure that is the case. Now, how far do we go up here? We need to go up 1 inch. Well, I guess we've already done that one. Now, this one, we really need to show more decimal places. So let's see if it will let us um, modify that one. Can we format that one? Let's see. General dimension. Usually it lets us change the number of digits. Oh, here we go. So we want 3 of those. I don't know if this is actually what we're looking for, but we'll put it back in play. Let's see. And that was indeed what we're looking for. Now this 0.5 is from another dimension. So there we have the one that's right here. All right, what else do we know? We know that it's 1 inch to the center of that. We also know this other one is 45 degrees. So, okay, I guess we can put that one in place. So here, there, and there needs to be 45. I don't know if that makes it fully defined or not, though. Do we know the distance right here? I am not seeing that. Is it fully constrained? It is. So I guess it just doesn't look like it should. And we could go back and look at our original dimension. Let's go ahead and save on that one. Um, on this initial extrusion, just to make sure it is indeed 3. Mm-hmm. But it just doesn't look like it's the correct shape. But what we can do is go ahead and forge ahead and then see if we'll get any kind of revelation as far as what it is. We do want to expand this one. We want to do a biplane. The total distance, I think, is going to be 2 inches because it's just going to be half an inch short on each side. So if we go 2 inches, you'll notice it goes right up to that line that we had before. Then we can say, does this really look like what we have over here? And to me, it does not. So I am going to pause and stare at this to figure out where my error is. Hopefully you saw where the error is, but I am not quite seeing it yet. No, I have a hunch that it's probably this right here. It looks like it's 2.5 to the bottom. That's most likely what we have uh, in error. So I'll go over here and then edit the sketch. And it's not this distance that's 2.5, but it's the entire thing. So let's go ahead and delete that. And we will go from there to there. That's 2.5. Let's see if this makes a difference. Sure does. And you can see it now looks much like it. So just that small error there, looking at that dotted line, had give us an issue. I guess we can hide this one right here. It was something we put on the foreground. We did have a sketch right here that I think we can now delete. Let's see. There we go. Now we need to draw a hole on this circle and probably go all the way through. This is a rod slide, so that makes sense that that should be the case. So if we right click on that surface, we can begin our new sketch and noticing that it's going to be 1 inch from the bottom on this circle. So just place it there arbitrarily. And then from here to there, along that surface, it's going to be 1 inch. And then also going from here over to there, also going to be 1 inch. And the diameter of this is going to be 1.5. Then we need to punch a hole in there. So let's do an extrude cut. And we'll just say through everything, so right there, and see if that is indeed the case. Looks like it. It doesn't say the object is not a through all hole. What we can do is go double check that by looking in the textbook here and just going all the way to the end of the chapter where the problem statement is, and just double checking everything right there. And you can see basically it says create the solid models and the associated two-dimensional drawings. Save the exercise in the chapter 9 folder. Okay, so it looks like we did everything right. We're gonna have to assume it's a through all hole. That gives us an interesting little shape back here on the back side, which is okay. I mean, sometimes you have parts that are like that, have this unusual cut in the back. Let's go ahead and set it up in this position right here. How about for right now, we not put the model-based dimensions on there, or model-based definitions. I may decide to take that off if we can go ahead and put all the dimensions on there on the drawing instead. Okay, so we want to make sure we get everything fully defined in the drawing view. So let's go ahead and save this one as part 9.1. Okay, let's skip the model-based dimension for this one. I changed the requirement so that you do not want to bother with model-based dimensions. We're going to put all the dimensions on a sketch instead. So let's go ahead and say File, New. Now we don't want to select this one right here. We want to go New up here and make sure that we select this one, IDW. So this would be Inventor drawing instead of just another type of drawing like that. ANSI is our standard. And what we can do is right click on the sheet and just kind of notice what its size it is. And I like the fact that this is a big sheet of paper, 22 inches high, 34. So this is like a big blueprint. You can lay it out like 3 feet almost in width. And so you normally use a blueprint machine to print this thing out. We're going to put it on a D size paper. What we could do is go ahead and zoom in down here and put a couple of things there. We always notice that these two are going to be filled in automatically as well as the size of the paper. Once we save the file name, that's going to go here. So all we really need to do is get the name of the part, rod slide, and the name of the university right here. So for that one, I guess we just go over here to annotation and start putting in some text. Remember, we just select the entire area like this, and then it's going to come up with a dialogue. You know what? And I think everything's supposed to be in all capital letters, so let's get in the habit of that. For blueprints, it's standard practice to always use capital letters. And we always want to center here and center this way. Looks like it could be maybe twice the size, or I don't know. Let's see if we can just go up to the 0.24 and see if that will work. Remember, you have to select the entire text before you change the size, though. So I didn't do that. And you see it's too big. So what we can do is type over it and just try 0.2. And see, that still doesn't fit. How about 0.175? And I try not to hit return because then it will, save it and move on. This looks really good, nice and professional. So we'll use 0.175 and let's see if the 0.4 inches work for our part file down here. So another one right here. Remember to put this in all capital letters. Rod slide, space in between. Select all of that and center, center. And let's make this 0.4. And usually I just click up here again to get it to accept that. That's going to be good. So 0.175 for this and 0.4 for that. In fact, I'll just go in here at this moment, pause the video and put those requirements in there. Okay, so you can see here I change it to a D size paper, put all this in caps. Oh, that should be 1.175. There we go. And 0.4 for this D size paper. We're going to remove one of these views because we really need to have what is called an auxiliary view for the circle that's on this face. So let's get started. Let's first of all save the file. So file, save as. Make sure it's going to save as a IDW file. And I guess we can go ahead and put that back in the previous directory. I'm on a different computer today. Okay, where's my new folder? Let's see. New folder. Okay, for some reason it's not doing that. So for me, I'm just going to come back to that later. So we need to call this part 9.1 like this. Just make a new file. Yeah, there we go. And for some reason, it's not making a new one. I'm not sure what that is. Finally shows up there. So that's odd that it didn't show up on the fly. And it didn't like the fact that I'm making that a new file, so a new folder. So I guess I'm doing it the wrong way. Okay, so let's go ahead and save it back in this one for now. And I'll come back later and fix that in the right project file. Usually when you save the file, that will then update the name down here to part 9.1. So now we have everything that we're looking for down here. It's time to put the views into position. Now, as normal, we want this to be the front view, and this is the right view, and then the top view is up here. So if you go back over to your part and it's not like this when you hit home, make sure that you rotate it around using these triangles until you get it to the home position that looks identical to this one, then right click and say set current view as home view. And then also on this one right here, if this is not your front view right here, then you want to move it to the correct front view, whatever that is, then right click and say set current view as front. That way, when you click home, it looks exactly like this. So everybody needs to look the same. That way, when we come in here and we say it's time to go ahead and start placing our view, the base view is always going to be our front view right here. And then the other views are going to be projected from that. And here's our new thing today, auxiliary view. So our front view is going to be this side right there. And I want it to be just kind of a wireframe once it gets done. I wonder if we can go like a 1:2 ratio on this. That makes it smaller, so 2:1. We might be able to fit that in. So then say OK to make sure it does go back to black and white. And you can see that there's our dotted line for this. Now, normally what you would do is you would do your projected view and you would show this one right here. But I'm going to see if I can get away with just doing a right view like this and then an isometric view maybe over here somewhere like that. Let's put it way over there. And I forgot to right click in that space and say create. All right. Now let's see if we can move this one over to the side. You'll notice we can't move it up and down because it's relying on the base view. So this is base view, and these two things are projected views. Now, what we want to do is an auxiliary view that's on this space right here. So let's see, identifier A, and then we want to select that surface right there, and then come back away from there. So let's see what's going on. Okay, I think all of that's good. And so this is going to be our view, and we want to come off in that direction there. So let's see if we can get that going. All right, there we go. I wonder what I was doing wrong there. So auxiliary view, then click on that surface or that line and say, okay, maybe I'm doing it out of order, looks like. All right, let me get this down so that y'all won't have to worry about this part. Yeah, it's doing something kind of out of order. So let's see, what if I collect the line first and then do auxiliary view? Does it let me do the thing out there? Nope. Okay, now it's starting to let me do it like that right there. What basically we're trying to get a view that has this as a circle rather than an ellipse that we would see in any of these other views. And I want to make sure I do that properly. So do we select auxiliary view and then the line? Nope, doesn't seem like it. We have to select the line first and then auxiliary view and then click it. It's hard to know which ones to do. Let's try this one. Select the line first, auxiliary view. And gosh, it doesn't seem like it's very, yeah, it doesn't seem like it's very intuitive on this one. Let me pause the video and look at the manual on this guy. Okay, so the manual says basically you select auxiliary view. Let's see if I hover over it. Oh, it's trying to tell me the order right here. Then it says select the face that we want to select, then drag and then click. Okay, I guess maybe I just wasn't doing it the right way. All right, so I click here, then come out that way. Click here and come out that way. So it looks like I had to click twice. One of them is to get this thing to appear, asking what the scale was, and then place it like that. I'll do it one more time just to make sure I understand. So auxiliary view, click once to show what the base view is, and then another time to click on the face that you want to make it perpendicular to. Now let's see if we can get all of these dimensions over here. And so we're going to do it by counting them to make sure we have the same number. Maybe the first thing to do is get the base in there. So let's do our annotations and start putting the dimensions. And it makes sense to do this one right here, first of all. So that one's going to be just, oh, it looks like it's just going to pull it in automatically for us. So if we zoom way in, you can see it does say 3 inches right there. We'll come back later and focus on getting the number of dimensions right. I'm sorry, the precision of that correct. I wonder if we can just say it right here. Yeah, it looks like we could change it right there, but it just might be for that particular unit. Let's see if we go over here to the document settings, if we can change that overall. Looks like it's got that. Yeah, so it looks like it just wants us to use the standard. So we will keep the 2-digit past the decimal throughout the whole thing here. Figure out maybe how to make the font bigger on this one. Now you can imagine that that font's going to be easily readable if we have if this piece of paper is 3 foot wide. So as we get for a D size paper. Okay, then we'll go down here and back on annotation, dimension. And so we're trying to just basically do the same kind of order we did before. Start at the bottom and then start working our way up. Now we know that this face over here is right there is going to be 1/2 inch. So just keep doing them in the same order. You could come out this way, but it looks like the ANSI standard is going to stick with this. Looks like we have all kinds of options about how to change up the formatting though, if we wanted to, but we're going to leave it just like this. Okay, now let's see. I guess that's to basically telling us it's symmetric. I don't know that we need that one necessarily, but we will mimic what this one is just so we get the same count. This is also telling the reader that this is a symmetric part. And the other thing is that we do not need to give the width of this one because it's basically 3 minus this minus that. So you notice they never really gave you the width of that one, so it's all good. Okay, and since this is kind of on the right side view, we might as well just stay over here and put in the dimension right there. This is a case where I think we do want to go into precision tolerance and change that to 1 up from there. So it shows identical to that. Looks like we could even, well, it kind of reduced that one on its own for that one. So now the front view is this way. So maybe that 1 inch would be a good idea to put over here. So for this one, you want to collect a point and a point to get the whole thing in there. And that's just beautiful. Looks really good. We don't need to change any of that. And then we also have the other side of this going from here up to there. And look how great that looks. Just really nice and organized. All right, then we got the 45-degree angle. Let's see if we can convince it to use this one and this one to get the angle like we did before. That's good. And then we also want to do the same thing over here. So between this one and this one, drawn out over there. So you can see it's on the front face like that. There's another 1 inch dimension that's horizontally like this. So you could actually give the dimension of that one, but what we're going to choose to do is do it exactly like they did over here and go straight up. Now let's see how many dimensions we've covered. It looks like we got all of those, and then all of this here. And so the only thing we have left to do is this view right here. And so that's what we really want to use the auxiliary view for right here. So let's come in here, and for the auxiliary view, go ahead, escape there. Dimension, and it looks like they're saying for this one right here, the dimension is, okay, had to activate it somehow. There we go. And then right here, looks like 1.5. Looks good. I guess it's going to ask me every time, so I might as well just make it look identical, just like that. And the other two dimensions are the inch and the inch there. So let's put those into position. So here to the center, and they have that pulled off to the side. And then also from here to this side, wait, let's see, let's make it go from there to there. Okay. And we'll call that 1 inch like that. Now let's just make sure we have everything fully defined. And also we have a couple more things to add. Like we got to make those show up like circles with the through holes through them. Um, but let's see, let's count them all to make sure we got right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, maybe I didn't count it right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, do I have too many over here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so I got 13 on both of these, and we do not put dimensions on this one. We normally leave it just like that. And we don't even show like the wireframe view. We don't show any holes through there. It's kind of, this is what you see on the tabletop, in other words. And these is with X-ray vision you see over here. Now, in this chapter, they also talk about how to label the holes properly as far as putting the proper types of lines on there. So let me pause and get that information for you. Okay, another requirement that's on here is the center marks. And you might remember that it's up here. And we need to put it on this circle. See the plus sign right there in the middle. Anytime you have a circle, you normally want to do that to help visualize where everything is, as well as make it clear. Let's see if it'll do this one here. Do we do it like that? Or this one? Should be able to a way to do it right through the middle of this one. Let me pause and look at the manual for that one. Oh yeah, there's another tool up here called Centerline. So let's look at that one, hover over that one. If you hover a little bit longer, it tells you which two areas to click on to put the center line through there. So let's click there, select here and there, and you see the center line going through there. That's nice. And then usually, I think you can actually drag it and make it bigger if you need to. Um, for example, over here, I think you can grab this one and pull it down this way if you need to measure more. Let's see if it's possible on these other ones as well. Yeah, it looks like we could do it like that if we wanted to. But I think probably just to right there would probably be good enough. So now we have kind of like how that one's sticking out a little bit. Let's do the same thing with this one, just a little bit beyond to represent the center line. So it says make sure we put center marks. Is that what they're called here? All right, center mark. I guess I should go in here and say, or center line to get those instructions clear. Okay, so to wrap this up, what we're going to do is label the views. And so what we're going to do is right click within the red borders here and say edit view. And we're going to call this one, let's see if the default is called. If we select this toggle label visibility and click OK, you can see it's called view AA. And the reason why that is because normally you have this line in between the two pointing back to the base view saying where this auxiliary view came from. In other words, if you go edit view and you go over here to this display option, select definition in base view. Now you can see that it has A and A right here, and it shows where it came from. Now we know what the base view is over here. It's really the front view. Let me see if I can get over here to the boundary of this one only. Right click, edit, and I think it's just called view one, but let's call it in all capital letters. Remember to do that, front view. And I guess we can leave the scale on there, hit the toggle for that right there. Now this would allow you to edit and put further details in there, but we're just going to do this. We don't want those overlapping, so we pull it down here. We could actually remove the scaling factor because if you look at the, oh, whoa, if you look at the sketch here to the lower right-hand side, it has the scale already there, which I guess is okay.
It's all about clear labeling and keeping things organized.
That's my AI kicking in there. So I don't know if you heard that or not. Now, if we want to remove that, what we do is just come down here and just remove the scaling factor like that. And that would just say front view. And let's just do that since we already have that, the scaling factor on the lower right-hand side. So like this. So now it's just getting what you normally put in there. And let's see what this one's going to be called here. Let's call it isometric instead of view number 3. Toggle it like that. Then we can hit this and I think remove that scaling factor because it's already on the table at the bottom. So there's our isometric view. I forgot to put the word view in there. Let's see. I guess what we do is right click, edit view, and type it right here. Got my cap locks on to make sure that we use the engineering standard of using all capital letters on engineering drawings. This one's a little bit low and pull that up so I can add my last view label. So edit the view. This is my right view. And then we can toggle it and then edit it, remove the scaling factor since it's already in the label. Click OK, and then let's move this down here so it's in the standard position. So right view is here, isometric view is there. My auxiliary view, also called the AA view, is right there. So let's see if we can get this to look full screen. Check out everything, make sure it looks good. Looks like there's a little bit of difference in the distance between this one and the other one. So I'll just kind of move it up a little bit just to try to align it here. I guess what we could do on this one, I guess it's understood that it's an auxiliary view just by saying view AA. I'll find out if there's another standard that is used instead. Okay, so I looked up the standard for what's listed here for this one, and they put the word auxiliary in there. So, by the way, this stuff over here is what's referred to as the datum, DATUM, and that's the title inside the chapter. Let me see if I can show you what I mean right there. So, datum features, that's the thing that's in brackets. We've already talked about auxiliary views as well. So, datum is just this right here. Now, let me show you where it gets this from. I think if we go right click and say edit view right here, the datum that it's referring to, let's see, is this right here. So it's going to put an A-A because the view identifier is the thing that's in the bracket. Let me do this again. So if we go over here and let's see, we're going to, I guess, oh yeah, edit the view here. And then we're going to edit the label of it right here. So it's going to use that letter twice. And you can see it's got the dash right here. So this right here in bracket is called the datum. Just another word for information, basically. And we call this auxiliary view. That's what the standard is. So capital, all caps, AUXILIA or Y, auxiliary view. Wonder if I do it like that, if it'll look okay. On the screen, auxiliary view. Looks like maybe 2 lines would be okay. Let's see if we can find a standard. I'm going to assume the standard is not to have a carriage return after it. So it's using the words that I typed with the datums, and then this is a dash that I typed right there. Actually, I put it in there by default. So here we go. Now we can see that this looks out of place because normally we're used to front, right, and top view, but sometimes you have to face the circle and create an auxiliary view instead of the top view. Or another view, but the base view is pretty much always going to be your front view like that. Let's go ahead and save this. So file, and well, I guess we've already saved it, but let's print this to a PDF file. So print, and we're going to select this top one. And we want to select PDF. Oh, looks like somebody texted me asking for filament. Let me pause the video right quick and get some 3D printer filament. Okay, where was I? All right, so best fit right here. And let's click OK. And let's just make sure that this prints properly. I call it part 9.1. That cap locks on. It should give it an automatic PDF name. And so if we go over here to the desktop, and there it is, let's make sure it looks good. That'll be what we turn in if everything's cool. Yeah. And you can see the print is really small here because again, this is supposed to be like 3 foot wide on that. But if you zoom in, you'll be able to tell that. And that's what I'll have to do when I'm grading these. So yeah, you can upload it just like that, and I'll be able to zoom in to make sure all of it's good. All right, good luck, folks, and I'll see you in the next video.